Welcome 1407 Computer Programming Lecture Series. Today we have to talk about the working with pointers. These are the main objective of the lesson. At the end of this lecture, you should be able to define the C pointers and its usage, should be able to describe pointer declaration and initialization, apply C pointers for the expressions, experiment on pointer operations, identify null pointer concept, experiment on pointer to pointer, pointer arrays, arrays with pointers, and apply these taught concepts for the writing programs. When you go for the introduction, to understand how to use pointers, you must have a basic knowledge of how computer stores information in memory. Pointers closely related to this memory manipulation. Basically, a personal computer RAM consists thousands of sequential storage locations, with each location being identified by a unique address. Computer processor also has their own memory, normally called registers, and the cache. You know that they differ in terms of access speed, price, and their usage. You know, the processor also has their own memory. We call them as a register and cache, and there is another memory storage, that is a RAM, and it also consists thousands of sequential storage spaces, locations. These memories differ them in terms of their access speed and price, and also their usage. Computer memory is used for storage. When program runs on computer and for processing data and instructions in a very simple way, each program requires two portions of the memory, that is the data portion and the instruction code portion. What is the data portion? For data or operands, data portion keeps the data or operand. You know what is operand? Operands. When you are writing mathematical manipulation, 2 plus 2, when you want to store 2 is a data part, or we call them as operands. The instruction portion, what to do to the data such as operators. Instruction code portion, it keeps the operators. Each portion is referred to as a memory segment. So there is a data segment, normally called data segment, and instruction code segment, normally called as a text segment. There are two segments, data segment and the instruction code segments. When the programmer declares a variable in C or C++ program, the compiler sets aside a memory location with a unique address to store that variable. The compiler associates the address with the variable's name. When the computer uses variable name, it automatically accesses the proper memory location. When the program uses the variable name, as example, we keep a variable x, integer type, x int x equal 5. What is the variable name? X is the variable name. It automatically accesses the proper memory location. The location's address remains hidden from the programmer, and the programmer need not to be concerned with what is that. Here I will take Here I will take, I think you can see my screen. Normally we are defining int x equal 5. In memory what will happen, it is just think for a while. This is the variable. This is the memory location. Name of the memory location is x. And we keep this data 5 in this location. And what does it says? When a programmer declares a variable in C or C++, the compiler sets aside a memory location with the unique address. Here it says there is an address for this. There is an address. Actually, this address is a hexadecimal value. F like that, this is a hexadecimal value. Normally, as programmers or users, we don't know what is the address of this location. We are not bothering. We name this location name as X instead of address. We access this data from this variable name. Okay. When the program uses this variable name, it automatically accesses the proper memory location. The location address remains hidden from the programmer. I think you understand that. And the programmer not to be concerned with it. No need to worry about the address. What we are going to do is manipulate the memory address by using pointers. We are going to manipulate the memory. Let's say we declare one variable named rate of type integer. Here this is the way of we are declaring the variable int. This is a data type. Variable name is rate and value assigned for that is 100. Memory allocation for the above variable can be depicted as the follows. Here this is the location. Here you can see my screen. Here variable stored value is 100. Inside the memory location it is stored the 100 value. And name of this location we put a name there, that is a rate variable name. And you can see there is an address for this location. We call that as a memory address. 1004 is the address of this location. You can see the memory address of this variable rate or any other name we can use. Here we have used the rate is a number. So can be treated like any other number in C++. Normally the number is in hexadecimal format. Here this address is a number, it is in a hexadecimal format. Then if a variable's memory address is known, the programmer can create a second variable for storing a memory address of the first variable. If we know the memory address, we can create a second variable to forward to store the memory address of a first variable. We can declare another variable to hold the memory address of this variable rate. Where here you can see variable name is rate. If we want to keep the memory address of this rate variable, we can create another variable to hold what data? To hold the memory address, which is a hexadecimal value. Let's see. Here this is example. At the beginning, s underscore rate is uninitialized but declared. Here this is the s underscore rate variable. It not initialized yet. No value is there. And rate variable is there. Value of the rate variable is 100. Memory address of rate variable is 1004. And this variable, memory address of this variable is 1001. S underscore rate variable, what we are going to store? We are going to store the memory address of this rate variable. Okay. Here we are going to store the memory address of this rate variable. That means 1004 should be there. No? If you want to keep the memory address of this rate variable, we have created another variable. Let's see. Let's store the memory address of variable rate in variable s underscore rate, so that this variable contains the memory address of the rate, which indicates its storage location in memory where the actual data 100 is stored. Here I want to store this memory address which is 1004 in this s underscore rate variable. Finally, in C++ vocabulary, the s underscore rate is pointing to rate, or it said pointer to rate. Here this s underscore rate variable is pointing to this rate variable. Here when you look at here, this is the rate variable. It is an integer type variable. It keeps integer type value. I have defined this s underscore rate variable. Look at here very carefully. This is the memory address is 1001. Here it wants to keep the memory address of the rate variable. We call that as this s underscore rate variable is pointing to this rate variable. This s underscore rate variable is pointing to the forward rate variable. In simplified form, here 1001, this is the location, and this should be a name. Name of this variable is s underscore rate. Value should be the memory address of this variable, that is a 1004. Clear? Here we call that is a s rate is not only it has to keep the memory address of rate variable. Therefore, we call that is s underscore rate variable is pointing to the rate variable. To declare that one, to show that it's pointing, we are using this pointer mark, that is a asterisk symbol. S underscore rate is pointing to the rate variable. Value of this is 1004. Clear? This is pointing to 1004 memory address. is the address, this is the variable name, and this is the whole data. Here this s underscore 8 variable holds the memory address. Okay. This is the way of the declaring a pointer variable. So the declaration of the pointer variable becomes something like this. Here integer, it is pointing to the integer type variable. Therefore we write int pointer $8, s underscore 8. S underscore 8 is pointing to which variable? It is pointing to a integer type variable, because rate is a integer type variable. If we call rate is floating number, float rate, then this s underscore 8 should be pointing to the floating point value. We can say float pointer s underscore 8. Clear? We called it this is as an integer because s rating is pointing to the integer variable. The asterisk is used to show that it is the pointer variable instead of normal variable. We are using this asterisk variable to show that it is a pointer. A pointer is a variable that contains the memory address of another variable where the actual data is stored. This is how declaring the pointer variable. Here pointer is a numeric variable, and like other variables must be declared and initialized before it can be used. Pointer is a numeric variable and it should be declared and initialized before it can be used. Here this is the following is a general form for declaring a pointer variable. Here we have to mention the data type, pointer variable name. Here char pointer x, meaning of that is x is pointing to the character value, character type value. Int pointer type of car, that is type of car variable pointing to the another integer type value. Float pointer value means value is pointing to the another floating value, point value. Here I will take here. You can see this is the memory address. It says char pointer x. Okay. This is x. I keep a there because char x equal a char x equal a. Okay, then it says there is a pointer that is pointing to the x variable. Okay, here this is not x actually. I'll put as y. Okay, and there is another variable, that is x. X is pointing to this character variable. Clear? Here char pointer x. That means this x is pointing to another variable. That data type should be a character type. Here y is a character, char y. Char y equal a. Okay. I think you get to understand that. Here, think for a while. I don't know, I have enough space. Here, memory address of this is a 100. Sorry, I don't have space for that. Here, memory address of this one is 1007 or whatever, any other value. That is the memory address of this place. The value of this is the x is this memory address 1007 or whatever. That means this x is holding the memory address of the y. Clear? Y is a character data type variable. Char pointer x. In next example, int pointer type of car. Here it says this is a variable. It said memory address is as a f. This is a hexadecimal value now. X0017 or whatever. And this is a integer type. This is a integer type. It can hold 50. Value of this variable is 50. I am creating a variable called x, pointer x. I can see int pointer x. That means x is holding a memory address of another integer type variable. X can be pointing to this z. X can be pointing to the z because z is a integer type variable. Here it's int pointer x means x is pointing to the another integer type variable. Then value of this location, this place should be, point x should be, what is the value? F107. That is the memory address of this z. I think you understood the concepts. Here float pointer value means value is a variable which is pointing to the another floating type variable. Pointers can be declared along with non-pointer variables as shown below. Here you can see char pointer ch1 and ch2. Meaning of that is ch1 and ch2 both are pointers to the type char. Float pointer value and the percent. Value is a pointer to a type float and percent is an ordinary float variable. Here float pointer value. This is a value is only the pointer. This is that meaning is value is pointed to the floating type variable and percent is just only normally ordinary floating type variable. It is not declared as a pointer. Once a pointer is declared, the programmer must initialize the pointer, that is make the pointer point to something. Don't make it point to nothing. It is dangerous. Normally, when we have declared the pointer, we have to initialize the pointer. You know what is the initializing? That means assigning value. We have to point that variable to somewhere else. Don't make it point to nothing. Please do not keep this only the creation variable creation and don't keep them without initialization. It can be dangerous, means it later I will explain why we call so. Like regular variables, uninitialized pointers will not cause a compile error. Although in our program we can define a pointer and we can uninitialize that one. But using some uninitialized pointers that could result in unpredictable and potentially disastrous outcomes can be there. Until pointer holds an address of a variable, it is not useful. Okay, normally as a practice, when you are declaring pointer, you have to initialize that one. C languages use 2-point operators. This is a asterisk we have already explained. This is a asterisk pointer. To get the address of operator, we use this and sign. Means return the address of. Meaning of that is it returns the address of the certain memory location. When address placed before the name of a variable, the address of operator returns the memory address of the variable. Here. Hence, a pointer variable can be initialized as follows: pointer variable name, and here you know s_8 is a variable name and that is a pointer variable. It can keep only the address of somewhere else. Then we can say s_8 equal and sign rate. Meaning of that is address of this rate variable. Clear? Here, this is an example. Int main, int n and there is a pointer, integer type pointer x. Okay, integer type pointer x. This is a n is a variable, integer type variable. It has given a printf n equal whatever value. It is also not declared yet, and printf n and sign n. We can get the address of the n there. Here and sign n means the address of n. Then it initialize n equal 10 and it print the n here and address of the n. Address of the n is what? Address of the n is the memory location of the n. Here this is the output. Okay, I will show that one. Here, this is the program. N equal 10 and x equal address of n. You know x is a pointer, that means it can keep the memory address of the integer type variable. Then it says x equal address of integer type n. When it printf x, what is the value? It should be address of the n. And we are keeping the pointer of x. We can use this pointer mark. Then it should be returned to what? It should be returned the data value of that it is pointing address. What is the data value of pointing address? That is 10. Then pointer x equal 10. X equal address of n, and we are using the pointer x equal value data value of the pointing variable, that is 10. Okay. In pointer m, there is a pointer variable m and location equal 200, that is the integer type value. M equal and sign location, that means m equal the address of the location. M is the integer type pointer, no? Then printf the data pointer m. Pointer m equal what? What is the pointer m? Value of this location. The address of the where data pointed is pointed to m equal value of the m. M is the address of the, it should return the address. And it's return false. I think you can understand this output. You have to try on this one and try to understand the output of this program. Here this is initializing pointer. Here pointer m receives the address of the variable. Location of memory address of the variable. Location is assigned to pointer variable m. Here you can see 1005 is the address of the m. Value is 200. 1005 is the address of this location variable. Okay. And pointer m is value of this pointer m variable is 1005. Clear? This value of this m variable is 1005. It is pointing to this location variable. Okay. Here this is the main method. Int count equal 10. There is integer type x variable and another variable pointer int pointer. What is this? Meaning of this is integer type pointer. Name of the variable is int underscore pointer. Int pointer equal and sign count. Int pointer equal address of the count variable and x equal what? X equal this int pointer. Here int pointer value is the address of this count variable. Pointer int point means the value of the count variable. Okay, this you can see this asterisk mark. Asterisk operator we can use to get the data part of this pointer variable. Okay. Here out should be count equal. What is the count value? What is the count value? 10. Count equal 10. X equal. Here it is. What is the value of the x? Point of int pointer. Point in value. That means the 10. Okay. X also 10. Count also 10. You have to try on this one. Here int main void char c equal q char pointer is the variable name and sign c. It keeps the address of the c. Here you have to try on this. Printf c equal c. Here char. When we use this char pointer with the asterisk value, that is the character value, that is the value of the c, that is a q. QC printf c char pointer, that is the value of the c. You have to try on this. Try to understand this program. Here what I wanted you to convey, you for a pointer, this name of, when we use the name of the pointer, this is a char underscore pointer, gives the address, memory address, and if you use this name along with this pointer symbol or asterisk symbol, it gives the data value of this pointing variable. Okay. The point operator appears before the pointer variable only 2 places. When declaring pointer variable, we have to use this pointer operator. When dereferencing the pointer variable, you know what is the dereference in the pointer variable here. Say x equal 5. Int pointer y, okay, y equal and sign x. That means in memory location, this is a pointer y, this is the x. Means y is pointing to x. Value of x is 5. Memory address is whatever I say, 1008. Here value of this y variable is 008. Okay. Then if we take int z equal pointer y. Here we are using this pointer operator to diff reference. Here meaning of that is z equal data part of this y referring value, y pointing value. What is the z? Here actually z is z. Z is integer type variable and value of z equal dereferencing pointer. That means this memory address data value, pointing value, that is 5. That's why it says we are using this pointer operator, asterisk operator, to declare a pointer variable, and second one is dereferencing a pointer variable to find the data it points to. I think you understand that. Here you have to try on these examples. Here. These things you have to try to understand what is the output. These are the outputs based on this theory part. Okay. Let's do the point operations. Only two arithmetic operations, that are addition and subtraction, available for this. In addition operation, each time the pointer is incremented, it points to the next integer, and similarly when a pointer is decrement, it points to the previous integer. For dereferencing, for example, two pointers that point to different elements of the same array can be subtracted to find out how far apart they are. Let's see. Let's take an example and here in this example, const int max equal 3. In the main program, you can see there is a variable var is an array of 3 elements, and there is integer I and the integer type pointer. Pointer equal var. Y is a array name. You can see let x have array address into pointer. For I equals 0 to I less than max, that is 3, I plus plus, printf address of var. Here you can see D means I, first element is 0, equal, here you can see percentage x, you can see that is a pointer value, that is a pointer, that is a address. Here it takes one by one address, and value of this one is dereference in PTR, that is a value. You can see from this program it gives the address of each element and the value of each. You have to try on this. Next is the pointer comparison. The comparison is valued only between pointers that point to the same array. Under these circumstances, the following relational operators works for the pointer operations. These are the relational operators that work for the pointer operation. A lower array element, that is those having smaller subscripts, always have a lower address than the higher array element. Thus, if the pointer 1 and PTR2 point to the element of the same array, the following comparison is true because PTR1 is less than PTR2. If PTR1 points to an earlier member of the array and PTR2 does, if it is so, this is true. Here meaning of that is PTR1 is pointing to the earlier member of array and the PTR2 is the later element of the array. This is the example, and these are the many arithmetic operations can be performed with regular variables such as multiplication, division, and do not work with pointers and will generate errors in C++. The following table is a summary of the pointer operations. You have to go to how to do assignment, indirection, and address these operations. You have to try on this. Okay.